Now that we've shown that taxes on producers and taxes on consumers have the same quantitative effect on a market, we can use that information to simplify the tax diagram that we can draw. So you can see here, I've started by just drawing our typical supply and demand setup. We have a supply curve, which we said before is a function of the price that the producer gets to keep for an item. We have a demand curve, which is a function of the total price that the consumer pays for an item. And we want to think about, without explicitly shifting either the demand curve or the supply curve, we want to think about how we can identify the new equilibrium when a tax is put in place. We can do that by recognizing that we have two additional pieces of information. The first piece of information that we have is that the quantity transacted in equilibrium when we put the tax in place has to be less than or equal to the original equilibrium quantity. We said that this was true before, and you can see in the examples that we did in taxes on producers and taxes on consumers, we showed that when you put a tax in place, you're reducing the quantity transacted in a market. So in fact, this relationship does have to hold. The other relationship that has to hold is that in equilibrium, the price to the consumer is equal to the price the producer gets to keep plus the amount of the tax. Well, this makes sense, and we've used this to find our equilibrium in our previous examples. Because we say, well, whatever the consumer is paying, part of it's going to the producer, and the rest of it is going to the government as the tax. So we can say, how can we incorporate this information into our diagram to figure out where the new equilibrium is? The first piece of information tells us that we're going to be looking for a new equilibrium to the left of the original equilibrium. So this tells us that this whole space out here to the right of the original equilibrium, for purposes of finding the tax equilibrium, it's going to be more or less irrelevant. So we say we're looking over here, and specifically we're looking for the point at which the price to the consumer exceeds the price to the producer by exactly the amount of the tax. So let's say hypothetically that our tax is this big. We're just going to represent it graphically. So I don't know what this is in numbers, but let's say it's this big. We can go over to our graph and think about, okay, where on our graph does this happen? And you'll notice here that the price to the consumer is going to have to be up here, and the price to the producer is going to be down here. So we can come over here and say, okay, we're looking for a gap that's this large. Well, I start here. Well, my gap is not large enough between the price that the producer gets to keep and the price that the consumer pays. So I have to keep going to the left until I find a point where the gap is exactly the correct size. And that's about here. Here we notice that the difference between the price that the consumer pays, which is what the demand curve gives, and the price that the producer gets to keep, which is what the supply curve gives, is exactly, or as reasonably as we can draw here, is exactly the amount of the tax. So this gives us our new equilibrium, and it really is that simple. That we can say here, this tells us everything that we need to know. If this is the point at which the price to the consumer and the price to the producer differ by exactly the amount of the tax, then this point has to be the equilibrium quantity when the tax is put in place. It also has to be the case that this point here has to be the relevant equilibrium price to the consumer. So we can label that as our P sub C star. And this has to be our equilibrium price that the producer gets to keep. And we can label that our P sub P star. And now we've identified everything that's relevant to our equilibrium when a tax is put in place. And conceptually, this is much simpler than actually shifting either one of the curves. This setup also shows why it makes sense to say that the effect of a tax on a producer and a tax on the consumer gives the same market outcome. Because if it has to hold, regardless of how a tax is implemented, that the price to the consumer and the price to the producer differ by exactly the amount of the tax, we can notice here that that's only going to happen at one point, unless we have a very odd situation where both the supply curve and the demand curve are both flat at the same time. That's not likely to happen, so what you'll notice here is if we're looking for a gap of exactly this amount, it only happens at one point to the left of our original equilibrium. So just by construction, the outcome when we put the tax on producers, where the gap was this much, and the outcome when we put the tax on consumers, where the gap in prices was also this much, they have to occur at the same point. In order to see how all of our models fit together, I've drawn the effective supply curve that we talked about when discussing a tax on producers, and I've also drawn in the effective demand curve that we talked about when discussing a tax on consumers. You'll note here that this is the point that we identified as the equilibrium when we talked about a tax on producers, and we said that this point here, because both the effective supply curve and the demand curve were in terms of the price to the consumer, this point identified the equilibrium price to the consumer, which is the same that we see in our wedge setup here. Similarly, when we talked about a tax on the consumer, we identified this point here as our equilibrium, and we said because the effective demand curve and the supply curve are both in terms of the price that the producer gets to keep, that's how we label our intersection price here. Again, the same as we have in our wedge setup. Also, in either case, the intersection of the two relevant curves is at this quantity transacted here. So we can show that all of these approaches give the same quantitative outcome. Some of them are just easier and more straightforward to draw than others. You should feel free, unless specifically told otherwise by your instructor, to use whichever approach feels most comfortable for you. We can also solve algebraically for the equilibrium prices and quantity with a tax via our tax wedge diagram here, meaning without explicitly shifting either the supply curve or the demand curve. What you'll notice is we have the following information. And what we'll do here is we'll go through the same example that we talked about before when we were modeling taxes on producers and taxes on consumers, so that you can compare the three different approaches. So you'll notice that the demand curve that we've been using is quantity demanded is equal to 50,000 minus 12,000 times the price to the consumer. The supply curve that we've been using is quantity supplied is equal to negative 5,000 plus 10,000 times the price to the producer. We've shown a couple times before, so I won't be too repetitive here, that the original equilibrium quantity before the tax was 20,000 and the original equilibrium price was $2.50. And then what we did was we asked the question, what happens in this market when a tax of 50 cents per unit is put in place? So what you'll notice here is that this all looks a little bit intimidating, because you'll notice that we actually have four unknowns. So quantity demanded is a variable rather than a constant. Price to the consumer is a variable rather than a constant. Quantity supplied is a variable rather than a constant. And price to the producer is a variable rather than a constant. Typically, we say when we have four unknowns, we need four equations in order to be able to solve for those unknowns. But what we notice is we actually do have four equations for our equilibrium. The first is just our usual equilibrium condition that quantity supplied and quantity demanded have to be the same. The second is that the price to the consumer has to exceed the price to the producer by exactly the amount of the tax. So we can also add in as an equation to use that P sub C is equal to P sub P plus 50 cents or 0.5. Now we have 4 equations to use. We can call this 1, 2, 3, and 4. The question just becomes, well, what exactly do we do with them?